Hi everybody, today we are still in problem set 1.1 and we are in question 4, exercise 4. The question is if we have two vectors in the question, v and w. Let's write them. Let's say v would be in blue and w would be in red. Okay, so v is blue and its components are 2 and 1. Okay, these are numbers because they are the components. This is a vector, so it has a small arrow. And W, let's write it in red. It's also a vector, you see the arrow. It has different components, 1 and 2. Okay, so okay, it's not the same vector because the order of the 1 and 2 is different. Okay, and if we want to know how much is 3 times v plus 1 times w, let's see, 3 times v plus 1 time w equals 3 times the components of v, which are 2 and 1. I'm just copying, plus 1 time w which are the components of w, which are 1 and 2. Okay, how much is that? Let's make it in purple because they are blue and red, so together let's say they are purple. Of course, if we don't have to do this, just to emphasize, 3 times 2 is 6, plus 1 times 1 is 1, so 6 plus 1. Let's make it in stages, okay? So I know it's not difficult, but for the next example we want to like, this is one of the first examples and I want to make it gradual. So 3 times 2 gives us, it's a new vector now that we have. It's no longer v, it's 3 times v. Okay, so we have, let's make it in green. 3 times 2 is 6. 3 times 3 times 1 is 3. Okay, so it's a new vector that we got, and together with the w vector that we had before, it gives us 6 plus 1. in the first component and 3 plus 2 in the second component, which is, as we know, 7 and 5. Okay, I'm no longer making it in like colors because it's not okay. It's not. I don't have a color that is a combination of green and red. I think it should be brown, but forgive me about the colors. Okay, so it's in blue, 7 and 5. This is the end result. Okay, this is algebraically. This is how they meant us to do it. Let's do it also geometrically. Okay, if we have a set of coordinates, okay, and notice that all the numbers here are positive, so I'm not drawing all the 4 quadrants, I'm drawing only the first one, okay, the positive x and the positive y. Okay, so I'm drawing it like this, instead of drawing a cross like here and here, I'm drawing more like the origin would be in the bottom, in the left, so I have more room to draw. This is x-axis. This is the y-axis. As you see, the positive direction is to the right in the horizontal axis, and the positive direction is to the upwards in the vertical axis. And we have, let's make numbers. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Okay, and if we want to draw the the v vector, let's draw it here. Remember, it's 2 in the first vector, which is the x vector, which is the horizontal vector, so 2 in the positive, because it's plus 2, it's not minus 2. So plus 2, it means 2 to the right, and 1 means in the y component, in the vertical component, is in the positive direction because it's plus 1, it's not minus 1, so it's 1 up. So 2 to the right and 1 up. Let's draw this in the same blue that we used for V. 1, 2 to the right and 1 up. We get to this point from the origin. This is V. Okay, if we want to draw W, okay, one more thing. If we draw W, okay, let's draw W. If we draw W, it's 1 to the right and 2 upwards, okay, because they are both positive. So 1 to the right and 2 upwards, it's here. Let's draw this. This is W. Okay, if we want to do the exercise that we had, it would be 3 times V. Okay, 3 times V, it's like taking V and taking another V. So it's again 2 to the right and 1 upwards. Okay, so this is another V, and from there another V, 2 to the right and 1 upward. I'm sorry, from here, 2 to the right and 1 upwards. This is another V. So together we have 3 V's. 3 times V. And we drew it in green, okay? But I don't want to mess around with the color. Like, this whole line should have been now, instead of 3 blue ones, like exchanging it for one big green one in this direction and in this length. But forgive me that I'm not like very consistent with this. If you want, I'll draw it. It's just I think that it will mess up the drawing. Okay, it's like if we did it in green here, and this would be 3V. Okay, and okay, let's draw it the rest of the exercise. So we take W. We went along the V. We step and step and step along the V, the 3V. We finished walking along the 3V. We got to the end, and now we take W and start walking along W from here. Okay, so W meant 1 to the right and 2 upwards. So from where we got 1 to the right, we get to 7, and 2 upwards, we get to 5. So 7 and 5. We get to here. This is W, okay? The same as this one, okay? We just copied it to here. And if we close the parallelogram, okay, this is also 3V. Then the sum of both of them, okay, let's make it in purple. The sum of both of them would be 3 times V plus 1 time W, okay, which is this line. Okay, this purple line, I will try to make it thicker. Okay, I hope you see that it's thicker. The thick vector, this is the thick purple vector, is 3 times V plus 1 time W. And this is, as you see, it's 7, 5. And this is the result. Okay, instead of walking along this one and then this one, or along this one and then this one, we can walk directly from 0, 0 to 7, 5. And this is exactly what we showed here. Okay, so now let's see what else they asked us. They asked us in the second part of the question, how much is CV plus DW? Okay, let's make a new page. So, CV plus DW. we try to make the two look different from Z or Z, okay? Because in the future we will use Z or Z a lot, and then we don't want the two to exchange with the variable Z. Okay, so plus D times W. W, you remember, was 1, 2. Just bringing it so you'll see. V was 2, 1, so I copied it here. And W is 1, 2, I'm copying it here. Okay, so how much is it? First of all, algebraically, let's do this exactly like we did before with the numbers. Remember, we had some number times V plus some other numbers times W, and we just multiplied and added inside the components. The first component with the first component, the second component with the second component, gave us the result of the first component of the result and the second component of the result. So we do exactly the same, but with the parameters instead of numbers. C and D are parameters. They can be any number. This is some number, this is some other number, or maybe they are the same, we don't know. So it means they don't have to be the same. I mean, they might, in an extreme case, be the same, but normally they are not the same. Okay, so let's write it like this. 2C and 1C plus, let's make this one in orange, 1D plus 2D, not plus, I'm sorry. 1D is the first component, 2D is the another component. We can't sum them up. It's like apples and oranges. We cannot combine them. Okay, and we have this equals to 2C plus 1D and C plus 2D. Okay, and this is the result. You know, it doesn't look like a vector, but it is a vector. This translates into a number, it's the first component. This translates into another number, it's the second component. Okay, let's see. It's exactly the same as this. 6 plus 1 was the first component, it gave us 7. 3 plus 2, the second component, gave us 5. Okay, let's see how it looks like we drew this one. Let's see what picture we get geometrically from this thing. Okay, so let's draw a axis, okay, so a coordinate system. Now I'm not drawing it only the first, I'm drawing now all the 4 quadrants, not just the first, all the 4, because I don't know if it's positive or negative. I want to show you that it can fill the whole plane, the whole XY plane. So this is the x-axis, the horizontal axis, this is the y-axis, and if we draw the first vector, V, let's say it's here, it's 2, I'm sorry, 1, 2, and 1, 2, and if we want to draw V, it's here, just like before. This is V. I know the beginning looks the same, but you will soon see that it's not exactly the same. And W is 1 to the right, and rightwards, and 2 upwards, so it's 1 and 2 here. Okay, so this is W. V and W. And if we want to see how much is 2 times, if we want to draw them, we don't draw through this, okay, we draw through this. Okay, we see that C could be any number. So V can be multiplied just like we went, if we multiplied, I'm reminding you, by 3, we went like, instead of V, we went along the same line. We put the ruler here, and we went 1 time, 2 times, 3 times. If we had minus, we go in the opposite direction. Okay, we went, if we had minus V, we would go to here, and minus 2V would be here. So it's the same, but it can take any point along this line of V. Okay, so let's just draw it here in a small like a dotted line here. Okay, so it can be anywhere here, and anywhere also in the negative direction. This is what I mean by the dotted line. Okay, and the W also got multiplied by some number, and which can be any number, positive or negative, plus 5,000, minus 300, whatever. So it can also be like not integer, it can be like 1/2. It can be pi, it can be any like number with numbers after the decimal point. Okay, so we have to draw the whole line of W because it can be multiplied by anything. It can be by half, so it's here. It can be by 2, so it's here. It can be multiplied by something negative, so it's here. So it can be anywhere on this line. Okay, so if we take this line V and we walk along it just like we walked here, we walk along, okay, we step, and we go to where they told us, instead of 3 times, C times, and we go up to C times V, and then we add as much as they told us in D. Okay, so do you see that we have, it's like we are copying this W, but not just to 3V, to anywhere. We are just dragging the W line all to all the possible positions here, and this is how, and because W is not just this long, it's very long, it's like infinite, it's on this line with the ruler, but to infinity in the plus direction and to infinity in the minus direction. So if we drag it along the whole possible V values to the plus and to the negative also, then we get the whole plane. Okay, so if we draw, let's demonstrate it with the ruler. If the ruler was infinite, and we would drag it to here and 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 to here, we would cover, and also to the negative, we would cover all the plane. The whole place would be covered with the possibilities of going along V and then along W, because we walk as much as we want along V to here or to here, and then as much as we want along W to here or to here, or to here or to here. We can get to any point with the combination of V, something times V, and something times W. Okay? So the answer is the whole plane. Okay? Let's write it. C times V plus D times W. As you see, these are vectors and these are just numbers or scalars or scalars. I don't know how to pronounce it. This covers the whole, or spans, like taking the whole plane. The whole XY plane. Okay? And this is the answer for the second part of the question. This is the algebraic version, and this is the geometrical version. Okay, so thank you and goodbye.